All right, today we are going to talk about how we can represent and find solutions for inequalities. And an inequality is very similar to an equation, but instead of there being one right answer, there's going to be many right answers. And one of the easiest ways to tell an inequality is the fact that it uses four symbols other than the equal sign. It'll use the less than symbol. This symbol right here with part of an equal sign would be less than or equal to. This sign here would be greater than, and then the same sign with one of the equals bars would be greater than or equal to. And I know in elementary they taught you that the alligator eats the bigger number or open end towards the bigger number. But how we determine which sign is which is just like what we read or how we read when we read a book. We read it from left to right. So if we start here, there would be a number is less than another number. If we put a number over here, this number would be greater than the other number. So we read them from left to right, just like reading the words on the page. Now, what an inequality does is it answers questions for things like if we take our equation from yesterday where income was 21 times the number of writers, and we wanted to figure out how many number of writers to equal one of our incomes, 9,450, our solution was that the number of writers was 450, and that would give us an income of exactly $9,450. Today, we use inequalities so that we can show things that would bring more than 9,450, or on the other side of that, if we wanted to know how many people it would take to get an income of less than 9,450. So we're going to take a look down here. Well, there was the bell. All right, so we're going to take a look down here, and it says that if 21 times I equals 9,450, then I would equal 450. So that any number I greater than 450 is a solution to the inequality 21 times I is greater than 9,450. A graph of these solutions on a number line is this. So we have this number line, zeros here, and then we would place 450 with an open dot. Open dot would be for less than or greater than, and then for less than or equal to, we'd have a dot, what we call a closed dot, or greater than or equal to would be a closed dot on our number line. And basically what that open circle is telling me that is any value of 450 or greater than 450 is going to be a solution to my problem. So 451 writers, 452 writers, 900 writers, all of those are answers to the inequality. So let's try solving one of these and graphing it, and then we'll apply it to just a very basic inequality. All right, so let's take a look at problem A from page 99. It says, write an inequality to help answer the question. Give 3 specific number solutions to the inequality, explain why they work, and then describe all possible solutions. It says the bungee jump at Wild World charges $35. How many jumpers are needed for the jump to earn an income of more than $1,050 in a day? So our inequality would be that if we're charging $35 times the number of writers, so we're going to go times n, and we want an income of more than, okay, so our income needs to be on the smaller end of things. So 35 times n needs to be greater than 1,050. And that's how we set up our inequality. Now, this works just exactly like an equation. Because we're multiplying here, our first step would be to divide both sides by 35. Okay? Because we still have that law of equality, okay, that states what we do to one side of the equation or inequality we do to the other side. So this turns into a 1. We're left with n, our greater than sign, and then 1,050 divided by 35. Now, I know that 3 times 30 is 90, so I'm going to say that 3 times 35 is going to go in here, and 3 times 5 is 15. You write the 1. 3 times 3 is 9, plus the 1 is 10. So 3 times 35 is 105, thus giving me a 0. Bringing down the other 0, we're just going to put a 0 up here. So n is going to be greater than 30 writers. Now, what this means, okay, is that n could equal 31, 32, 33 customers, okay, or any number greater than 30, because our solution was that n was greater than 30. Okay, now this is going, any number of customers greater than 30 is going to give us an income greater than $1,050. Okay, now we're going to go ahead and describe this on a number line. So I'm going to make a number line down here. And every year we do this. Kids think they need to have these great, wonderful number lines. And they don't need to be great. You need to have a 0. And then since our number is 30, okay, n is greater than 30, I'm going to just put another line, write a 30. Okay, now, this is the part of graphing that comes. I'm going to look at my sign. It is greater than. It will not include the number 30. It will include every number greater than 30. So instead of me coloring in the dot, I'm going to use an open circle at 30, and then I'm going to draw a line. Yeah, there's the other bell. I'm going to draw a line extending to the right, thus showing me that any number 31, 32, so on and so forth, is going to be an answer. Now, a question that we need to look at real quick is, would 30.5 work? Mathematically, yes, 30.5 would work, but logically, since we're talking number of customers or number of jumpers in this case, we're not going to have half of a person jumping, or they're not going to charge less for half of a person or whatever. However, it's not a realistic answer for this situation. So we're only looking for whole numbers that are greater than 30. All right, now we are going to go on to a different question. 84 is less than 14 times n, and we read that as 84 less than 14 times n. We're going to solve this, and we're going to graph it on a number line. So the first thing we have to do is we have to draw the line showing both sides of our inequality. And since I'm multiplying here, I will divide by 14 on both sides to get this to a 1, leaving me with m. And then I'm going to just bring down my sign of less than. And then 84 divided by 14. 84 divided by 14 is 6. Okay, so 6 is less than m. And that's going to be the solution to my inequality. But in order for me to write this on a number line, I'm going to switch places. I'm going to rewrite my solution as m is going to be greater than 6. Notice how when I rewrote this that the 6 is still on the smaller side of m. M still gets the open side. It's still greater than 6. Right here, m is still greater than 6. So on a number line, we're going to draw a number line. And again, these don't have to be very fancy. We're going to put 0, and since this is a positive 6, 6 will go to the right of 0. We're going to put a 6, and it is greater, m is going to be greater than 6, which means 6 is going to be the smallest solution. And we're not going to include 6 because there is no greater than or equal, or in this case, less than or equal to. So we are going to put an open circle at 6, and since the solutions will be greater than 6, we're going to draw an arrow extending to the right, showing me that things like 7 and 8, all of those are going to be fit the solution, because if I take 8 times 14, okay, just to show you, 8 is greater than 6. 8 times 14, this would be 32. 8 times 1 is 8, plus 3 is 11. And then if I fit this in there, I have 84 is less than 112. And this was my 14 times m side. Okay, so 84 is less than 112. Thus, 8 is a solution, but so is 9, so is 10, any number greater than 6. Now, there are many different things. If we had an equal sign here, if this was one of these where it was less than or equal to, we would have a closed dot instead of this open dot, okay? Or if it was greater than or equal to, both of these result in a closed dot because it includes that number in the solution because it can also be equal to that. All right, well, I am going to stop talking. This has become a very one of the longer videos. Feel free to go back and watch it. We are going to start with these in class tomorrow. Be a good idea to walk yourself maybe through B before coming to class, or at least A, going back and reviewing the solution for A and how that applies. All right, see you in class.